Exercise 10.02. Now, when you see this, remember, is a concave down parabola. Faces downwards, concave down. It's like a cave, and the cave faces downwards, and this faces up. This is a concave up parabola. Whenever you draw a parabola, you'll always get to the top of the parabola if it's concave down, or you'll reach the bottom of the parabola if it's concave up. Well, this value, the y value up here is called the maximum value, and the y value down here is called the minimum value. We don't worry about the x value. It's the y values that we're worried about. So the vertex, see that corner there, that turning point? That's called the vertex of the parabola. So that's called the vertex of the parabola. And down here, this is also called the vertex of the parabola. So the vertex of a parabola of the form y equals ax squared plus c. That is the only type that we look at in this course. Remember, the plus c is if it's shifted up or down. If the c is positive, it shifts up. If the c is negative, it shifts down. So the vertex will be on the y-axis. That's the y-axis. And always at the vertex, you've got x value 0, and then you'll have some particular y value up there, all right? Now, here I've got the vertex represents here the maximum value of the parabola, and here is the minimum value of the parabola. So what we're going to do today, we're going to use quadratic functions, which are formulas with x squared as the highest term in them, to sketch different graphs, and then we're going to find the maximum and the minimum values, all right? But we're going to put them in context of problems, all right? So, got that, vertex, concave down, that's got a maximum value there, concave up, that's got a minimum value down there. Now, the first question here is to draw a neat sketch of each parabola without plotting points. We don't want you to do a table of values. I might just get you to plot 1 or 2 values, that's all. Marking the coordinates of the vertex. Now, you tell me what you know about this parabola. Is it steep or is it wide? Okay, good. It's steep. And it's been shifted where? Up or down? So it's steeper and it's shifted up. How much? 3 units. So that means it's normally it would sit here. It would look like this. Normally, can you see my dotted line? Normally it would be there, but it's shifted up 3 and it's quite steep. So I'm going to draw it steeper. Now, I would like, so that's my shifted up 3. If you want, y equals x squared would be down here, the normal x squared graph. Are we okay with the normal x squared graph? You can, if you want, draw the normal x squared graph if you want in pencil. This would be, down here, would be y equals x squared. I don't want that graph. I want to draw y equals 4x squared plus 3. It's steeper than the other one, and it's been shifted up 3 units. Now, you know what? It's not a bad idea just to plot me 1 point on the graph apart from this point. Now, I know that's my vertex. How could I plot another point on the graph? You substitute. Well, when x is 1, so don't do when x is 0. When x is 0, y was 3. That's the minimum value of the graph. But when x is 1, what would y be? You substitute it into the formula. Just to give me one other point on the graph. When x is 1, what do I get? Y is 4 times 1 squared plus 3. Do you get that?
7.
Another point on that graph, I would have the point 1, 7. Now, this is not to scale, all right? I don't want you drawing all the dots everywhere. Do you get it? So and what I've done here, this y equals x squared, you might want to draw it dotted or something just to show where it would have been. Does that make sense? This would have been y equals x squared here. But I've drawn y equals 4x squared plus 3. Now that y equals x squared, it's probably not a bad idea just to draw it very faintly and to dot it so that you know roughly where it would have been. So my y equals x squared, I'm just going to do it dotted, all right? That's where it would have been. 4x squared plus 3 is steeper and shifted up 3. The 4x squared makes it steeper and then it's shifted up 3. Okay? Now, we're going to draw the next curve. Just a quick idea of what it looks like. Y equals, so I'm drawing y-axis, my x-axis. You tell me about that curve. What do you think? Negative, tell me about the -3 in front of the x squared. Is it concave? So this one is concave up. That first one was concave up. Is this one facing, don't worry about the -2. Yeah, this is facing downwards, so concave down. It shifted down 2. Shifted down 2 units. Is it steep?
Somewhat.
Yeah, and it's steeper. Steeper than your normal y equals negative x squared curve. Now, I probably should have lifted this up a bit. So it's sort of going to look like shifted down to pretty steep like this. Okay, that's what it's going to look like. Because the normal x squared curve, the negative x squared curve, the normal one is like this. The dotted one, if that is y equals negative x squared, I'm trying to make that black one quite steep. Okay, what would this point be here? How far down has it been shifted? -2. And I want to put a point. I'm going to do a substitution. When x is 1, you're going to have to tell me what y is. Yeah, it's -3 times 1 squared minus 2. I'm trying to work out that when x is +1, so if this is 1, what my y value is going to be. Now, I'm just going to make a bit more room here. I'll write concave down here. So concave down. And I'm just going to make this a bit bigger because I haven't left much room for it. And it's got to be fairly steep. And it's facing downwards. Okay? So when x is -1. -3 times 1 squared. Now 1 squared is 1. So -3 times 1 is -3 minus 2. That's -5. So when x is 1, y is -5. That's a point on the graph. 1, -5 is a point on my graph. Okay? So notice it's quite steep. Y equals x squared might look like that, the dotted one. But this is steeper and shifted down. All right? Do you get it? Girls, I'm only doing 1 point on one side because these have symmetry. You only need to draw one side and then you just mirror. You draw this side and the other side's the mirror image of it in that line in the y-axis. Now, state whether the quadratic expression has a maximum or a minimum value. See this first graph here, does that have a maximum or a minimum value? So the first one has a minimum value of what? Of 3. Of y equals 3. So that's for this equation. So the equation y equals, so for the equation, so that's for that graph. For the equation y equals 4x squared plus 3, it's got a minimum value of 3. Can you see? It's got a minimum. What about the other one? Has it got a maximum or a minimum? This graph. Maximum or a minimum? It's got a maximum of -2 is its maximum. So for the graph of y equals -3x squared minus 2, it has a maximum value of y equals -2. It's always the y value you look for. Do we get that, girls? Here show the height in meters of a plane in a power dive. All right, the plane goes down and up. So the plane's going to go down and up, okay? Is given by this parabola, by this function. H equals t squared minus 10t plus 80. Now, girls, this is not a straight line. I know you can see the 10t plus 80, but the t squared makes it a parabola or a quadratic function. When the highest power of your function is squared, you've got a parabola. Now, normally, we see y and x, okay? So normally you would see y equals x squared minus 10x plus 80. That's how you'd like to see it. All right? You know how that's your y-axis and this is down here your x-axis? That's how you would normally see it. But in our thing, we've got h equals t squared minus 10t plus 80. So we have to graph this function, okay? Now, we know it's a parabola. I know it's different to the ones that we've been graphing. It's different because of this minus 10t in the middle. You're used to seeing t squared plus 80 only, all right? Not this 10t. But if you can see a squared and it's your highest power, it's a quadratic. It's a parabola, okay? This minus 10t means not shifting up or down. It's shifted sideways to some degree. But that's not part of this course. So all we've got to be able to do is substitute. Now it says use a table of values to graph the function h equals t squared minus 10t plus 80 for values of t from 0 to 10. So let's go. So normally you would see y equals x squared minus 10x plus 80. You know, when you see this, t, the value of h depends on t. So we do different substitutions for t. And we start with 0, 1, 2, 3, 4, 5, and I will keep going with 6, 7, 8, 9, 10 on the next page. Oh, well, down here. T, H, 6, 7, 8, 9, and 10. So let's go. When H is 0, when T is 0, here's my equation. Now, T is 0, you should be able to just do that one in your head. 0 squared is 0, minus 10 times 0 is 0, plus 80. What do you get? 80. Now, if you want, you can do them on your calculator, but let's just try in our heads. What's 1 squared? 1. Minus 10 times 1. Do them on your calc if you want. Do you know how to substitute, girls? You are substituting. T is 0. Then you do T is 1. Use your calculator. 1 squared minus 10 times 1. We know 10 times 1 is 10. You don't have to write 10 times 1. You just go 1 minus 10 plus 80. Because you know that 10 times 1 is 10. So what do you get for that one? Anyone? Sorry? 70? No, it's 71, I think. Right. When t is 2, 2 squared is 4 minus 20, that's negative 16, plus 80. Is that 64 or something? Just use your calc if you want. When t is 3, 3 squared is 9, minus 10 times 3 is 30, minus 30 plus 50, I think, plus 80, that's 50, 59. When when t is 4, we get 4 squared is 16, minus 40, plus 80, 56. When t is 5, we get 5 squared, 25 minus 50 plus 80, 30, 55. Good. When t is 6, oh, 50, sorry, what did I get here? 56, 55? Yep. Oh, did you get 56 for 6? Good. So, girls, we've reached the minimum and we're coming back up. Look, you look and see what happens. 49 minus 70 plus 80. What do you get? I think you get 59. Do you get 59 next? Yeah. Can you see what's happening? Look at the numbers. Keep going. T is 8. 71. No. I think it's 64. Yep. T is 9. 81 minus 90 plus 80 is 71. And t is 10 gives me 100 minus 100 plus 80. Girls, can you see a pattern? Look. 80, 71, 64, 59, 56, 55. Back up to 56, 59, 64, 71, and 80. Can you see the pattern? All right, so from here, just sketching this graph. So we've done a table of values for values of t from 0 to 10. So we go 0, 1, 2, 3, whoops. Actually, that's not 3, that's 3. 4, 5, 6, 7, 8, 9, and 10. And this is time in seconds. And height, I think we go up by 10s because we need a maximum height of 80, 10, 20, 30, 40, 50, 60, 70, 80. Okay, so when t is 0, height is 80. Remember, this is a plane in a power dive, so it'll go down and come back up. When t is 1, we've got 71, which is halfway. This goes up by 2s, so we've got 70, 72, 74, 76, 78, 80. So that's 71. When t is 2, we've got 64. So 62, 64. T is 3, it's 59. So it would be halfway between 58 and 60. It's going to zoom in now. Then we've got 56 and 55. So when t is 4, we've got 56. Now that's 50, 52, 54, 56. T is 5, we've got 55. Now you know when you've reached the minimum of the parabola when, so for example, here I've got 56, here I've got 55, then it goes back up to 56 for 6 seconds. Because it's symmetrical, this minimum value here is 55, but I've got a 56 on either side, which is 1 step away from there, which is 1 second on either side away from there. I know that 55 is my minimum. All right. T is 7, we've got 59, and notice how it's symmetrical. Because I've got 55, then I've got 56 on either side, I've got 59 on either side, and for 8 seconds here I've got 64, and that's on either side, and at 9 I've got 71, and for t is 10 I've got 80. So it is symmetrical. You can draw a smooth curve. Remember, it's a parabola, it's a smooth curve. Okay, so we've just done part A, use the table of values and graph the function. Okay, so, all right. Now we can see here that this is our minimum there. Okay, now the coordinates of the vertex. Vertex is where the is where the minimum of the parabola is. So the coordinates of the vertex are, anyone? What are these coordinates? That's the vertex. It's 5, 55. Okay? So the coordinates of the vertex here are 555. The minimum value of h is 55. So the minimum value of h is 55 is the minimum. And what does it represent? It represents the lowest that plane. It's 55 meters. Yeah. So the minimum is 55 meters. It represents the lowest point, the lowest height of the plane. So it represents the lowest height of the plane. So the plane drops down to 55 meters and then comes back up. Okay? Oh, what is the lowest height? It's 55 meters.
Yeah.
Oh, when? There we go. So D, when? When is the lowest height of the plane reached? At 5 seconds. So the lowest height is reached at 5 seconds. And the height of the plane at the start of the power dive is? Yeah, the height, 80 meter height. The plane is at 80 meter height at the start of the power dive.
So you have to write that whole sentence?
No, just 80 meters. Okay? All right, so that's a fairly straightforward one, that one. The temperature at a town n hours after 6 a.m. is given by this function. Graph this function of values from 0 to 15. Look, we wouldn't need each value. I just threw that table in there myself. So let's just, when it's 0, so when n is 0, you don't need to put this one in. What do you get? 14. And when n is 1, You get 1 6, negative 1 6 plus 2 plus 14, 16 minus a sixth.
You get 15.8.
You get 15 and 5 sixths. When n is 2, you get 4 there. N squared is 4. Negative 4 sixths plus 4 plus 2 times 2 is 4. You can put it on your calculator if you want. For 18 minus 4 sixths. Isn't that 17 and 2 sixths or 17 and a third? I'm just doing them in my head, but you would put it in on the calculator if you want. But I'm doing them on the calculator, in my head. Because look, you're putting n is 3, for example. I'm just doing this bit first and then I'm doing that bit. If n is 3, isn't that 2 times 3 is 6? Plus 14 is 20. And then I'm taking away 9 on 6, which is 1.5. That's 18.5. But you can, do you want to try 1 or 2 on your calculator? Okay, I'm going to come back once I fill this table in. They range from 6.5 is the lowest to 20, which is the highest. Look, we're not going to be able to graph it this accurately. 5, 10, 15, 20. That's what we're going to have to do. 0, 5, 10, 15, 20. So I'm going up like that. 0, 5, 10, 15, 20. So 2 boxes is 1. In other words, 1 box is a half. Okay? This would be 2.5. So every square is 0.5. Now that's doable. That's okay to graph. So every little square is 0.5. So choosing your scale is really important. So I'm going from 0 to 20 because the maximum's 20. And my time goes up to 15. I'm going to go up by 2s as well. 2, 4, 6. Oops, that's not 6. You can't see it very well. 6, 8, 10, 12, 14, and 16. Okay, so that, remember to, sorry, that's n. And n in hours. N is hours after 6 a.m. And this is T for temperature. So T is temperature, N is hours after 6 p.m. Let's start graphing 0 and 14. Remember I said every two boxes is 1, or every one little square is a half. So I've got 0 and 14. 0, if that's 15, 2 little boxes down is 14. Because every little box is a half. Look, I'll zoom in here. I've got 10, 11, 12, 13, 14. Every 2 boxes is 1. Okay, the next one is 15 and 5 sixths, which is about 15.8-ish. So for, you know what, I just graph every second. Don't graph every single one, but we've got to make sure that we got the maximum in there. Don't graph every single one. No one expects you to graph 15. Do 0, 2, 4, 6, 8. Yeah, decimals are fine. 7. All right. So 2 is just 17 and a third, which is, if that's 17 and that's 17.5, about there. Just under 17 and a half for 2. I'm only doing every second one. 19.3 recurring is 4. So that's 19. 19.3 would be about here. It's just under 19.5, right? 6 is 20. I'm only doing every second, so I'm doing every second. It's just too hard to do every single one. But of course, we've got to do 15, okay? I'm only graphing every second one. 6 is 20, done that. 8 is 19 and a third, which is symmetrical now, just making sure it's the same as that. Because that's 19, 19 and a half, I'm going in between. 10 is 17 and a third. You don't need to do the ones in between. 12 is 14. 14 here. So notice it's symmetrical there. The parabola is symmetrical. If I was able to draw the rest of it down here, it would be symmetrical, okay? But the parabola starting here from this particular, parabolas really do start, like go from there and come all the way down here, but I've started it not at the very beginning. That's what's happened here, because the parabola's been shifted. The next one, I'm just going to do 15 is 6.5. So 15 is halfway between 14 and 16. So this is 5. That's 5. 6 is 2 boxes up. 6.5 is 3 boxes up from 5. Okay? So I'm just going to join those now. You should really use a pencil. Smooth curve. Don't worry about the ones in between. They will fit. You don't need to do each one. Okay. There we go. And we stop there. All good? Just do every second one. Okay? It's better. I mean, we can check. 14 is 9.3 recurring. It probably should be a little bit lower, but it's good enough. All right? Okay. Let's start. Are we good? Did you sketch them? Girls, do you understand that every box is half? Right? You've got to get your scale right. I wouldn't be going up by 10 boxes makes 5. 10 little boxes makes 5. Each box is a half. Okay? At 6 a.m. Now you've got to read the context of the question. It's n hours after 6 a.m. So these aren't the times down the bottom. This here is 6 a.m. because n is the hours after 6 a.m. All right? So 2 is actually 8 a.m. So you've got to read the question carefully. So what was the temperature at 6 a.m., girls? That's the start time. It was 14 degrees. At the temperature T degrees at a town, n hours after 6 a.m. So 0 hours after 6 a.m. is 6 a.m. Time 0, any 0 represents 6 a.m. 2 hours after that is 8. And 4 hours after that is 10. And 6 hours after that is 12 noon. Do we get that idea? Yes?
Yeah. Miss, when we draw the graph, do we have to bring it down?
No, you just stop there. Because it just says you only draw the graph up to 15. Okay, so that's 6 a.m. 6 hours after that, that's 12 noon. All right, so the next question was at 2 p.m. Where's 2 p.m.? At 8 hours. And we can look up here too. We can look up here. 2 p.m. is 8 hours after 6 a.m. Temperature at 2 p.m. is 19.1/3 degrees or 19.3 recurring degrees. So temperature at 2 p.m. is 19.3 recurring degrees. I'm assuming this is Celsius. It is. Next question. What was the maximum temperature and when was it reached?
20.
Yeah. So the maximum temp is 20 degrees Celsius and it is at 6 hours. At n is 6, which is 12 noon. Okay? They want the time. Estimate to the nearest half hour the times when the temperature reached 19 degrees. And why are there 2 answers? So you need to come across at your graph at approximately 19 degrees. We will be able to with this. Okay? Graph at 19. If that's 20... Remember, didn't we say every 1 box is half a degree? 2 boxes is 1 degree. You put a line across here. And the estimate, look, if 19.1/3 degrees is 4 and 18.5 degrees is at n is 3, it's somewhere between, isn't it somewhere? So it's between 9. Well, this is, if that's 8 a.m., 10 a.m., this is 9 a.m. So, look, it's approximately, I'd say approximately at 9:30. At approximately 9:30. And there is another time. When else is it? Between these two. And approximately between, no, it's got to go below 19 and approximately 2:30. So, girls, if it's above 19 there, and if it's below 19 there, then between 8 and 9, it will be 19. So we're saying it's between 9 a.m. and 10 a.m., which is 9:30, and between 2 p.m. and 3 p.m., which is about 2:30. So we're going to say to the nearest half hour, and it's asking you for half hour times. So it's, what did we say? Between 9 and 10, so 3:30. Sorry, not 3:30. 9:30 a.m. and wasn't it between 2 and 3, which is 2:30 p.m. So it was at 9:30 a.m. and 2:30 p.m. Question E. So this was at 9:30 a.m. and 2:30 p.m. And E, for how many hours to the nearest whole number was the temperature 19 degrees or higher? Okay, we know that the temperature is 19 degrees or above. So just looking here, for how many hours was the temperature 19 degrees or higher? The temperature was 19 degrees or higher for this section here of the graph, which I will highlight for this section here. And we just worked out what those times were in the question before. So between 9:30 and 2:30, the temperature was 19 degrees or higher, so you've got to subtract those two times. So we've got from 9:30 to 2:30 is 5 hours. It's 5 hours. 10, 11, 12, 1, 2. And F, this quadratic model is only accurate for values of n from 0 to 13. Why do you think the model does not hold for values of n above 13? Up till 13 hours, which is about here. So what will happen is overnight, the temperature will just stay the same, and then it'll start coming back up again in the day. So only this part of the model is good, all right? Because if we continue this model, what's going to happen? You're going to get to below 0. That only really happens, well, it doesn't happen very often here in Sydney, but like, it doesn't just keep going to minus 20 and all that, all right? So, the model does not hold. And you know what also happens? See how it goes down quite slowly here, but then it goes down really quickly as you get further and further. Like your quadratic equation, if you draw a parabola, down here it's a slow turn, but as you get up, it goes up quite quickly, all right? So, model does not hold for values above n is 13 as the values drop very quickly and will become negative. Become negative. Okay, that's what will happen according to the model. The values will become negative according to the model. And you could say, e.g., overnight minimum temperatures are reached, and the temperature tends to stay there. Overnight minimum temperatures are reached. Temps are reached. And then the temperatures go back up. In the day. Okay, so that's not going to, you can't keep continuing that model. All right, is that okay? You know, your temperature just stabilizes. It does go down a bit through the middle of the night, then it heads back up. That's really what happens to the temperature cycle. It goes up and down, but the model is only good till about there. All right, and then we have to ignore the model after that. All right.